So good morning. So today's topic is the last thing. So what we are going to see it of Avena, we are going to see the what are the path planning approaches. That is what are about the classifications of path planning approaches. So we'll have a two different things. One for the methods, which is exploring for a search graph, and the next one methods incrementally building a search tree. Okay. So what is the difference between that and path Avena? So for the search graph, we'll be going for an attempt to capture the topology. Okay, and similarly, we'll be having about the pre-processing of the space and multiple query types. Sorry, ma'am. So we'll have a single query type and we'll be having of a multiple query types over on it. Okay, so when we going for an examples for exploring a search graph, we'll go for ordinate diagram, cellular decomposition, and theorem. So whereas for building a search tree path, we'll be going for an algorithm and rapidly exploring random trees over. Okay. So next thing, what we'll have over on it path now. So these are the two methods which explore the search graph and implementing building a search graph tree. Okay. So next, what we're going to see it of again now. What are all the potential feed approaches? So in the case of an potential feed approaches, we'll have a heuristic function. So in the we'll have an artificial potential field. That is, we have to define the configuration space to steer robot towards the goal through the gradient process. So whereas in the case of an random box in the pathology, they be used to escape local minimum traps over it. And particularly, it is efficient for holonomic planning, but it depends on the choice of a good heuristic function. So while we are using a good heuristic function, so definitely it just makes us a difficult one. So we will have when obstacles and differential constraints will be added to the problem. Okay. So what are all the approaches of being part now? The first thing we'll have a probabilistic growth graph. So அதுல வந்து அப்ப graph வந்து என்ன பண்ணுவோம்னா which will be constructed on the space இருக்கும். So it will generate a random configuration and it will attempt to connect paths of nearby configurations. அப்ப local planning வந்து will be efficient. Okay. But connecting configurations பார்த்தோம் அப்படின்னா it is a difficult task, so particularly for complicated non-holonomic dynamical systems. Okay. So the next thing we have to define the dynamic model of a manipulator. So robot dynamics. Robot dynamics அப்படின்னா it is the study of the relation between the applied forces at task and the resulting motion of an industrial manipulator. Okay. That is similarly kinematics மாதிரியே we have to define two models over on it. One to be the direct model and other one to be the inverse model. So direct model பார்த்தோம் அப்படின்னா there is once the fork at the task which is applied to the joint. Okay. So as well as joint positions and velocities வந்து known இருக்கும். What we have to compute அப்படின்னா we have to compute the joint acceleration. எதுல direct model அதாவது force position velocity எல்லாமே தெரியும். We have to compute the acceleration. But inverse model அப்படியே reverse சொல்லுங்க. What will have over on it? There is once the joint acceleration, velocities and positions known ஆயிருக்கும். But we have to compute the force or the task. Okay. So this is the dynamic model. So once the manipulator வந்து பார்த்தோம் அப்படின்னா which is composed by an open kinematic string. So dynamic model வந்து which is affected by the drawback. So we'll have a low rigidity, elasticity in structure and the joints over it. So potentially நம்ம என்ன பண்ணுவோம் அப்படின்னா we'll be having of an unknown parameter